So on Thursday, at the lecture I went to at MIT, the professor, Aaron Pinkston, I think was the professor's name, he was talking about doubly infinite series. So instead of just a series like this, 1 plus 1 plus 1 plus 1 plus 1, which he said this series, by the way, is equal to minus a half.
Okay.
Is that a surprise?
A little, yeah.
Little. It is kind of a surprise, by the way, because if we add it to our other series, we get 1 minus 1 plus 1 minus 1 plus 1. This was a half, right?
Yep.
So if I add these together, I get 0 equals 2 plus 0 plus 2 plus 0 plus 2 plus 0. Right.
Which is strange because if this is minus a half, this appears to have the same amount of like value that this does.
Because you can just like
You can
two as one.
yeah, you can take a 1 out of this 2 and put it here. Like 2 plus 0 can turn into 1 plus 1, but it somehow changes the value of the series.
Yeah, so he was sort of using this to kind of demonstrate that you got to be careful when you're doing things with these infinite series. So, but anyway, let's just take this as a given, that this is what this guy Aaron Pinkston was talking about. But then he said, what about the series that goes ... plus 1 plus 1 plus 1 plus 1 plus 1 plus ... So it's infinite on both sides.
So you have somehow more 1s.
Right, there's no sort of natural starting point.
Hmm.
You have infinite going that way and infinite going that way like we had before. What do you think this sum equals?
Well, you'd have no room for an equal sign.
That's true. That's true. You do have no room for an equal sign, but we could write it like this. We could use the sum notation. From minus infinity to infinity of 1. Now we have room for an equal sign. What's your guess for this crazy series?
Well, shouldn't infinity times 2, it should equal infinity.
Or it could equal minus 1/4 if you're multiplying. Because you were doing from 0 to infinity before, so maybe you have twice the numbers somehow.
Well, technically we're doing from 1 to infinity before.
Well, it's still roughly twice the numbers.
Okay.
So maybe it's minus 1/4. Maybe it's
What if we had twice the numbers? Why would I get minus 1/4?
maybe no, minus 1. You're not. It's not that way.
Okay.
But
So maybe I get minus.
maybe
1.
you get minus 1.
Uh-huh.
Maybe you stay with minus 1/2.
Yeah.
So maybe it doesn't matter.
Right. So he said one way you could think about this is you could pick a middle point if you wanted. And then this was the series we had before.
Yep.
And this is also the series we had before, just going the other way.
So
So this would be minus a half plus 1 minus a half, which is
0.
0.
that is very strange.
Yeah.
It's weird that you can do that.
Yeah, so this series, it turns out to be 0.
Because you could also, but what if you did something like, if you took this series from here and from here.
Yeah, that's a great observation, actually. This actually shows, we can even do that right here, like this.
Yeah.
We can, instead of starting here, we can just start here, right? So this is the same, this should be the same as 1 plus the same series we had before, right? So this should be minus a half, but minus a half definitely does not equal 1 plus minus a half. So this is sort of demonstrating that shifting
Create problems.
can create problems.
Yeah.
So these are some of the series he was talking about. And then he even got into crazier series where instead of just summing, if you can imagine summing the integer points on a line, he did it in a plane and 3 dimensions. So like infinite on the plane, infinite in 3 dimensions. Crazy, huh?
Yeah.
So these series are studied by mathematicians, and they have very unusual properties, and they have properties that are very difficult to understand. But I wanted to show you the shifting problem, only to point out that what they were doing in the number file video was kind of glossing over some potential problems. So, anyway, what do you think? Do you think this is interesting, or do you think this is just pure mathematical nonsense?
I think it's pretty interesting.
Pretty interesting, but also pretty weird.
Yeah. Okay. That's what a lot of the people at the talk on Thursday thought too. All right. High five. Good job, guys.